Welcome to the Deep Dive. Today we're tackling a topic that's almost guaranteed to come up if you're aiming for a senior software engineer role, GraphQL.
Yeah.
It's not just about knowing what it is, it's about understanding its place in modern architectures, especially, when you're dealing with microservices, and being ready to discuss its trade-offs like a seasoned pro.
Exactly. Interviewers at this level, they really want to see that you can think critically about technology choices. They're less interested in whether you've simply used GraphQL and more in your grasp of why you choose it, what the potential pitfalls are, and, well, how it fits into a broader system design. GraphQL, with its nuances in a microservices context, is a perfect area to demonstrate that depth of understanding.
So let's get straight to it then. What's the core problem that GraphQL steps in to solve?
Yeah.
Especially in these, distributed microservices environments that are so common now.
At its heart, GraphQL is about fixing the inefficiencies of how clients fetch data. Think about a typical mobile app needing information that's spread across several different backend services. The old way often meant multiple API calls, and, well, each of those calls could bring back a whole lot of data the app doesn't actually need. Overfetching.
Right, yeah.
GraphQL offers a kind of, well, a more precise way. It delivers only the essential data, cutting down on that bulk of overfetching you often see with traditional REST in complex systems.
Okay, let's make this concrete. Imagine you're building a mobile app that shows a customer their recent orders. How would that work?
Right. So to display that, you'd likely need customer details and a list of their recent purchases.
Okay.
In a microservices setup, customer info might be in one service and order details in another. Traditionally, you might hit the customer service and get a full profile, even if you only need the name. Then you'd call the order service and get tons of order data details about every order, perhaps, but you only care about the date, amount, and shipping status for the last few.
That sounds incredibly wasteful. All that extra data transferring over the network, slowing things down, especially on a mobile device. Plus, more battery drain, right?
Precisely. GraphQL turns that model around. Instead of the server deciding what to send, the client, our mobile app in this case, gets to specify exactly what it wants in a single query. The app sends a GraphQL request asking specifically for the customer's name and the date, total, and shipping status of their last 5 orders. One request, exactly the data needed.
So one precise request replaces potentially multiple overfetching calls. That's a huge win for performance, especially on mobile. And it means you don't have to build these one-off API endpoints on the server just to aggregate specific data for a particular client view.
Exactly. You avoid creating and maintaining these custom server-side aggregation layers, which can become a real headache over time. To enable this, a microservice exposes a GraphQL endpoint. Think of it as a single front door that all GraphQL queries go through.
Okay.
This endpoint uses a schema to understand what data is available and how it's structured.
And this schema acts as the rulebook, the contract between the client and the server, detailing what data can be asked for and how different pieces of data relate. I've also heard there are tools, graphical tools maybe, that make it easier for developers to write these specific queries based on the schema.
Absolutely. There are graphical tools like GraphQL where developers can explore the data landscape defined by the schema and visually construct their queries. This can really speed up development and, reduce errors.
Now, going back a bit, I recall that when GraphQL was newer, a big limitation was that it primarily worked with JavaScript. Has the landscape broadened since then? Is it more stable now?
Oh, it's evolved dramatically. Initially, the GraphQL ecosystem was heavily JavaScript-centric, but that's really no longer the case. You now have robust libraries and implementations available for almost every major programming language and platform: Java, Python, Ruby, Go, .NET.
Okay.
This widespread adoption makes GraphQL a much more mature and, frankly, less risky choice for organizations today compared to its early days.
That's good to hear. It's clearly moved beyond being just a niche technology. But like any tool, it has its downsides, right? What are some of the key challenges and things to consider if you're thinking about using GraphQL, especially with microservices? This feels important for that interview context.
This is definitely where that critical thinking comes in, the kind interviewers are looking for. One major area of concern is the potential for those client-driven, highly flexible queries to overload your backend.
How so?
Well, because clients can ask for precisely what they want, they also have the power to construct incredibly complex queries. Think nested data, lots of relationships. These could put a significant strain on your services. It's kind of like giving clients the ability to write their own database queries. We all know how poorly optimized those can sometimes be.
Right. A poorly written SQL query can bring a database to its knees.
Right.
So a complex GraphQL query that digs deep into nested data across multiple microservices could have a similar system-wide effect. And it sounds like tracking down the culprit might be harder than with SQL.
Exactly. Unlike SQL, where you often have query planners and performance analysis tools built into the database, pinpointing the exact part of a complex GraphQL query that's causing a bottleneck across a distributed system can be significantly more challenging.
So while you gain flexibility for the client, you might introduce new headaches for the server in terms of monitoring and performance tuning. What are some strategies to handle this potential load? Throttling, maybe?
Server-side throttling is one common approach, yeah. You can set limits on the complexity or depth of GraphQL queries that a client can execute.
Okay.
For instance, you could use complexity scoring to estimate the cost of a query before running it. However, implementing this effectively in a microservices environment can be tricky.
Why is that?
Because a single GraphQL query might fan out to multiple independent services, and coordinating that throttling or cost analysis across them adds another layer of complexity. You need some way to aggregate that cost.
Okay. What are some surprising or maybe less common approaches teams are taking to address the server-side load issue with GraphQL?
Good question. I've heard of some teams using query cost analysis actually at build time, rejecting overly complex queries before they even get deployed. Others are exploring adaptive throttling based on real-time system load, adjusting limits dynamically. But it definitely feels like an evolving area, you know?
It does. Another aspect that seems more complicated with GraphQL than with, say, REST is caching. REST has those standard HTTP caching mechanisms built right in. How does GraphQL compare?
You've absolutely hit on a crucial point there. Caching with GraphQL is indeed more intricate than with REST. REST APIs can leverage standard HTTP response headers like cache control to tell clients and CDNs how long to cache responses based on the URL.
Right, because each resource often has its own URL.
Exactly. But because GraphQL typically uses a single endpoint, like GraphQL, for all types of queries, those built-in HTTP caching mechanisms don't apply in the same straightforward manner. It forces a shift in caching strategy.
So if everything goes to the same GraphQL endpoint, how do you, invalidate the cache when underlying data changes? Say a customer updates their address. Standard URL-based invalidation doesn't work.
Well, the common practice is to ensure that every type of resource returned by your GraphQL API has a unique identifier, usually a global ID.
Okay.
The idea is that client-side applications can then use these IDs to build their own local caches. If a client requests the same resource again, maybe by its ID, it can potentially retrieve it from its local cache. But this puts a lot of the caching burden on the client.
Right. What about things like CDNs or reverse proxies that sit in front of your services? Can they still help with GraphQL caching?
That's where it becomes much more challenging. Because the PSD body, the query itself dictates the data being requested, and these queries can vary widely, it's much harder for standard CDNs or reverse proxies to cache responses effectively based on just the endpoint URL.
So you can't just cache based on GraphQL.
No. You'd likely need to implement additional logic to make caching work at those layers. Maybe analyzing the query itself, hashing it perhaps, to generate a cache key. This adds significant complexity and isn't something most CDNs do out of the box for post requests.
Yeah, that sounds tricky.
Yeah, exactly. You might end up having to build custom solutions or rely on specific CDN features if they exist. I've come across some implementation-specific caching solutions, particularly within the Apollo client ecosystem for JavaScript, which does sophisticated client-side caching based on object IDs. But it really seems like caching wasn't a primary first-class consideration in GraphQL's initial design compared to REST.
It was more of an afterthought or something left to the implementation.
It feels a bit like that sometimes, yeah. Now, if your queries are very user-specific, very dynamic, the likelihood of cache hits might be low anyway. In those cases, the lack of simple request-level HTTP caching might not be a major drawback. The benefit of precise data fetching might outweigh it, but it's definitely a trade-off to consider, especially for data that could be cached effectively.
This makes me wonder if these caching limitations sometimes lead teams to adopt a hybrid approach. Like using GraphQL for some things and sticking with traditional REST for others, where caching is easier.
That's a very valid observation, and it's a pattern you absolutely do see in practice. For instance, for highly dynamic or personalized data where caching isn't very effective anyway, GraphQL's efficient data fetching might still be the primary benefit.
Okay.
But for more static or broadly cacheable data, maybe product catalogs, reference data REST might offer simpler and more readily available caching strategies using standard HTTP.
That makes sense. We've talked a lot about data retrieval, the query part of GraphQL. What about modifying data, the writes? The documentation mentions mutations, but it doesn't seem to be its main focus compared to queries.
Right. While GraphQL does have mutations for writing data, it often feels less naturally aligned with those operations compared to REST. REST has distinct HTTP methods like post, put, patch, delete, each with pretty clear semantics for create, update, and delete operations.
Yeah, those verbs are intuitive.
They are. With GraphQL mutations, you define custom mutation types, but it doesn't have that same built-in semantic richness for different kinds of writes. This often leads teams to a practical division of labor, using GraphQL mainly for fetching data, queries, and sticking with REST APIs for handling data modifications, writes.
So GraphQL for reads, REST for writes.
It's a common pattern. It can simplify the overall architecture, allows you to leverage the strengths of each approach where they fit best, and avoid some of the potential complexities around designing and securing mutations.
Okay. Now let's shift focus slightly to maybe a more architectural philosophical point. I've heard the argument that GraphQL can sometimes create the impression that microservices are simply data providers, like glorified database endpoints. Can you expand on why this perspective can be problematic?
This is a more nuanced but really critical architectural consideration, especially in a microservices context. Because GraphQL emphasizes clients asking for specific data fields, it can unintentionally lead developers, and maybe even architects, to think of the underlying microservices primarily in terms of the data they expose.
As just data buckets.
Kind of, yeah. And this undermines a fundamental principle of microservices, which is that they should encapsulate business logic and expose distinct functionalities or capabilities, not just raw data access.
So it's more than just a database wrapper.
Exactly. It's not just about semantics. Thinking this way undermines the very purpose of microservices achieving independent business capabilities and maintaining clear, bounded contexts. A GraphQL schema that too closely mirrors the underlying database tables of various microservices can be a red flag. It might signal a failure to properly abstract the domain logic within each service.
It's like that old anti-pattern of anemic domain model, but maybe at the service level. The microservice just becomes a thin layer over its database.
Precisely. The comparison sometimes made to OData, which is more of a generic data access protocol, is relevant here. While GraphQL isn't exactly the same, its strong focus on flexible data querying can sometimes steer development in that direction if you're not careful. It's vital to remember that microservices are about behavior and capabilities.
Okay, so how do you avoid that trap? How do you design the GraphQL API correctly?
Your GraphQL API should be designed to expose the functionality of your microservices in a client-friendly way, but it absolutely should not be tightly coupled to their internal data storage mechanisms. Changes in an underlying microservices database schema shouldn't automatically force breaking changes in your GraphQL schema.
It needs a layer of abstraction.
Yes. Your GraphQL schema should reflect the capabilities and the domain model of your application, seen from the client's perspective, not just the physical structure of your databases. This helps maintain the independence and evolvability of your individual microservices.
So the GraphQL API should act as a kind of facade, abstracting away the underlying implementation details of the microservices, including exactly how their data is stored.
Exactly. It should be a representation of your business domain and the actions or queries that can be performed within it, rather than a direct, leaky reflection of your database structure.
Got it. So given all these considerations, the benefits for clients, the challenges with load and caching, the architectural nuances, where does GraphQL really shine in a microservices architecture? What do you say is its ideal use case, its sweet spot?
The consensus, and what generally makes the most sense, is that GraphQL is particularly well-suited for the edges of your system, specifically for those external-facing APIs that serve client applications, especially user interfaces and mobile apps.
Why especially those?
Well, think about the limitations of mobile devices we mentioned: bandwidth constraints, battery life, data usage concerns. GraphQL's ability to let the client fetch only the necessary data in a single request provides a significant advantage there, minimizing waste and improving perceived performance.
Right, that makes perfect sense.
Absolutely. And we've seen prominent examples like GitHub adopting GraphQL for their public API. Their experience really highlights the benefits for external APIs, where clients, maybe third-party developers, often need to make numerous REST calls to piece together all the information they need. GraphQL can significantly streamline that process and improve the developer experience for those API consumers.
So fundamentally, GraphQL in a microservices context often serves as a kind of call aggregation and filtering mechanism, primarily for the benefit of the client.
That's a great way to put it. It often acts as an orchestration layer at the edge, taking a single client GraphQL query and making calls to various backend microservices to gather the required data, then stitching it together into the shape the client requested.
Okay. And it's important to understand that GraphQL isn't intended to replace general communication between microservices themselves, right?
Correct. That internal service-to-service communication would likely still rely on other protocols and patterns, maybe synchronous REST calls for simple requests, or asynchronous messaging via queues or event streams for more decoupled interactions. Those are generally better suited for backend service communication than GraphQL typically is.
The documentation also briefly mentions the backend-for-frontend, or BFF, pattern as another approach to consider for this client-backend interaction problem. We don't have specific material on BFF today, but it seems like both GraphQL and BFF are strategies for optimizing that interface between backend services and client applications.
That's a good point to bring up, yeah. They both aim to tackle the challenges of building client apps that need to consume data from multiple backend services, but they approach it with slightly different philosophies. GraphQL offers a more generalized, flexible query language where the client dictates the data requirements on the fly.
Whereas BFF is more tailored.
Right. The BFF pattern typically involves creating a dedicated backend service, specifically tailored to the needs of one particular front-end application or type of client, like a mobile BFF, a web BFF. It acts as a simpler, more focused facade for that specific client. So GraphQL offers more flexibility to the client, while BFF offers potentially simpler backend logic focused on a single client's needs. Different trade-offs.
Okay, that helps position it. So let's try to synthesize this as if we were summarizing for someone prepping for that senior technical interview. What are the essential points about using GraphQL in a microservices world that they should absolutely be ready to discuss clearly?
Okay, key takeaways. First, they need to clearly articulate how GraphQL provides significant benefits for client-side data fetching, especially for mobile apps or complex UIs. That means talking about precise data requests, reducing overfetching, and minimizing network calls.
The core value proposition.
Exactly. But second, they absolutely must demonstrate an understanding of the potential challenges and trade-offs. That includes the risk of increased server load from complex client-defined queries.
Right, the performance aspect.
The added complexity of caching compared to standard HTTP caching with REST.
A caching headache.
And crucially, that architectural danger of inadvertently blurring the lines between microservices as capability providers and just simple data stores. They need to show awareness of that potential anti-pattern.
So it's definitely not a magic bullet. It's a powerful tool, yes, but it comes with important trade-offs that need careful consideration in any architectural decision.
Precisely. They should be prepared to discuss where GraphQL is most effective, typically at the system perimeter, serving external clients with specific, often varying data needs, and understand its role as an aggregation and filtering layer over your existing microservices, not a replacement for internal communication.
And I guess tying it back to the senior level interview.
Yes. Perhaps most importantly for a senior-level interview, it's about demonstrating an understanding of how the choice between GraphQL and other API patterns, like REST or BFF, reflects a deeper grasp of the overall system architecture, the specific requirements of the client applications, and the operational implications. Showing you've thought through these nuances, weighed the pros and cons in context, that's key.
Absolutely. It's about showing that you can weigh the advantages and disadvantages, understand the architectural implications, and make informed, reasoned decisions based on the specific context of the project, not just following a trend.
Exactly.
This has been a really insightful discussion. Thanks for breaking down the complexities of GraphQL in a microservices world so clearly.
My pleasure.
And for those of you preparing for your technical interviews, hopefully this deep dive has given you a solid foundation to build on when you discuss GraphQL.
Happy to help. And remember, it's not just about knowing what GraphQL is, but really understanding why and when you would choose it and being able to discuss its trade-offs intelligently. That's the senior level thinking.
Couldn't agree more. And on that note, here's maybe a final thought to mull over. Consider how the increasing adoption of things like API gateways and service meshes might further influence how GraphQL endpoints are deployed, managed, secured, and maybe even cached within a large microservices environment. It's another layer of complexity and opportunity to think about as you continue your own deep dives. Until next time.